This is video number 2, dilations. This is the third transformation we are going to be learning. So transformations, it's what you do with an image if we give it to you. On video 1, we learned about translations, which is a slide. So we slide the image. We learned about reflections, where we flip the image. And remember, in both instances, we do not change the size. No change to size or angles. When we are dilating it, that is what we're going to learn today. Right? This changes the size. Right? So it changes size, but the angles do stay the same. Okay, this is what we're going to be looking at today. For the next video, we will be looking at rotations. Alright, and that is when we turn the image. Alright, next slide. Alright, so let's get started. Make sure you have paper and you're taking notes. Transformations, just like what I said, it is what you do to a 2D figure. You can translate it, reflect it, dilate it, reflect it. Oh, I said reflect it twice. That should be rotate. Alright. Remember dilations, this is what we're going to be learning today. They change the size. Alright. And the images are considered similar for dilation. So if I have a little heart and then I change its size, they are similar, and that's the symbol for similar. Okay, remember this is approximately. Right, this represents similar, meaning they are proportional. Alright, they are proportional, but the angles do all stay the same. So whatever the angle was from here to here, it should still be the same angle from there to there. And we usually see it when we're actually dealing with like polygons. 90 degrees, if I make it a little bigger, that should be a little longer. That looks like a horrible example. So if I have this rectangle and then I make it a little bigger, if this is 90 degrees, this one should also be 90 degrees no matter what. So the angles stay exactly the same. Alright, next slide. Alright, so this is where we are today, the second lesson, dilations. Today we're going to see how dilations create similar figures. Remember, that's the symbol right here. Similar does not mean congruent. Right? It does not mean congruent. And just a little review. This is the equal symbol. This is the approximate symbol. This is the similar symbol. And this is congruent. These are the symbols that we will come across. Next slide. A dilation is a transformation that moves each point along a ray, coming from a fixed point. All right, and it does not need to be an origin. It does not need to be the origin. In dilated figures, the dilated figure is similar to its pre-image, not congruent. All right, so if I have a small one and I have a bigger one, right, it's not congruent. It's not the same exact size. It's similar, meaning it's proportional. The side length changes, but the angles stay the same. So what is it talking about this ray? This is what it's saying. If I have, for example, this one's at the origin, it does not need to be at the origin. It's saying that if I'm if I draw lines like this, they will all correlate. Think of an image that you may put in a Word document. Okay, so say that's the picture in the Word document. And if you were to click right here and make it bigger, it usually, the whole thing will get bigger in a proportional way. But a lot of times now, right, that feature is disabled, so if you were to move it from here, just this side will be longer, or if you were to move it from here, this side will be taller there. But usually it's supposed to go straight across diagonally, right? That's what this is saying. You're stretching it along, all right? So same kind of thing here. So if you look at it, you can kind of figure out where that fixed point is going to be. It just means that it's stretching along that, and it can get bigger and bigger and bigger. All right, next slide. So there are 3 different types of dilation problems that I'm going to be asking for you to do. The first one is to identify them using pictures and shapes. All right, so here's an example right here. All right, down here, for the second one, if I give you a figure with dimensions, right? So for example, here's a dimension like 3 by 2, 4 by 4, and I want you to dilate it. Remember, dilate means to make bigger or smaller. That's what this is representing right here. How am I going to dilate it? This stands for scale factor. All right, that's what you multiply by to get your new image. All right. 3, I give you a figure with coordinates, or if I give you a figure on a graph, you can use those coordinates with the scale factor and tell me what the new coordinate will be, and possibly draw that new picture for me. All right, so there are 3 different types that we're going to go over today. Next slide. So this is type 1, identify them using pictures. It says which are dilations. So let's just try to figure out which ones are dilations in these 2 examples. And it says look at the measurements. Well, I know that the dilations all have to be proportional. So they all have to make sense. So if I'm looking from D to C, here's D prime and C prime. How do we get from 8 to 16? Well, that's times 2. Okay, so let's make sure from here to here, oh, that is still times 2. From 4 to get to 8, that's times 2. So what about if I have 8 here, what will this one be? 16. Okay, so my scale factor here is 4. Let's make sure, let's see if I do 4 times 2, does that make 8? Yes. This shows a dilation. This is a dilation because it's proportional. It's the same scale factor on all sides. All right, whatever I multiply by is the same number though all the way around. Let's look down here. Okay, well here's C and here's A. Well, here's A prime and C prime. So this side corresponds to this side. All right, and then C and B, so C and B go correlate to this one, and then A and B correlate to that one. So this is what I'm going to do. I am going to, actually what I could do is just redraw it, and it doesn't need to be perfect. So 15, A, 6, B, 12, and C. I'm going to redraw this one on the side and write it in the same order. And right now this is just for reference, so it doesn't matter that it's not the same exact size. So I just try to make it as similar as you can. From B prime to C prime, that is saying that it's 4. From A prime to C prime, it's saying that one is 5. From B prime to A prime, that is 2. So all I did was just redraw it because over here it's kind of turned in a way. So I just want to make sure I'm seeing this all correctly. Alright, so let me check it out. How do I get from 15 to 5? Okay, I can divide by 3, but dividing is not my favorite, so maybe I want to go the other way. How do I get from this side to that side? Oh, well, that's times 3. What about this one? Times 3, what does that equal? 6, matches. Times 3, oh, equals 12, it matches. This is also a dilation. Okay. So here's one way in picture form that I could ask you. Just make sure that the corresponding sides match. So B prime and A prime do not correspond to the side length AC. Those are different coordinates. So A prime, B prime should go with this one right here. Okay. So look at it that way. All right, next slide. All right, here's another one. It says, which are dilations? So let me look. I have ACB, ACB. It might be a good idea to redraw that. And again, this is much smaller than this one, but that's okay. I'm just trying to draw it out. All right, here's the 90 degree, so I know that one's C prime, and then this one's B prime. A to B is 4. C prime, well that was A prime to, yeah, okay. So C prime to B prime, C prime to B prime is 5. A prime to C prime is 3. So let's see if it is a dilation or not. All right, how do I get from 8 to 5? That doesn't look like it goes in very easily. And then from 4 to 3, let's come back to that one. That one doesn't look right now. Those numbers don't really correlate, so this is not a dilation. It's not proportional. And how could you tell? Since you can't really multiply or divide by anything to get this number evenly, you can say 4 divided by 3. Right, and 4 divided by 3 is like 1.33 repeating. Now I can do 10 divided by 4. Right, 10 divided by 4 is 2.5. These are different numbers. So that just proves right there that this first set of images are not considered a dilation. Now let's look down here. We're trying to see if these are dilations. So this one has 2 lines. This one has 2 lines. Okay, so I'm going to redraw that one. I'm going to put 2 lines up here, and I'm going to put, let's see, this one has 1 line, so I'm going to put the 1 line here. This one has my 3 lines, so I'll put my 3 lines there. Now let me write these numbers right here. It doesn't have points here, it just has numbers for the lengths. That's okay. The 3 belongs between the 1 line and the 3 lines. So 1 line, 3 lines, that would be 3. 2 lines, 3 lines, that would be 4. And 2 lines and 1 line, that would be 2. Now let's check. How do we get from 12 to 2? Well, we can divide by 6, that equals 2, okay? 18 divided by 6, that equals 3, matches. Divided by 6, that equals 4. This is a dilation. Okay, it's the same thing all the way around. I divided by 6 the whole way. Or I can say I multiplied by 6 all the way around to get these values here. All right, next slide. So this is type 2, but I have something to say back with type 1, so let me go to the other slide again. The point of giving you these examples like this right now is to show you that it has to be proportional, meaning that it has to be the same scale factor all the way around the image. It can't just be one side length multiplying by a number and then the other 2 by a different number. It has to be the same scale factor all the way around. And hopefully that could be a little clarified in type 2. Next slide. I give you dimensions, here's my scale factor. What that means is I'm going to make this dimension here 5 times as big. So all you are going to do is multiply the x value and the y value by 5. So I get 20, 30. That's my new coordinate. But what about if I have the scale factor be 1/2? Well, just multiply by 1/2. 8 times 1/2 is the same thing as 8 over 1 times 1 over 2, which is 8 over 2, which is 4. It's just saying what's half of 8? 4. So what's half of 16? 8. There we go. If you notice, for here, my scale factor is 5. 5 times as big, they got bigger. From 4 by 6 went to, I wrote it as a coordinate, but it really should be 20 by 30. Okay, so this one should be it right here. And here, I wrote it as a coordinate, but really it should be 4 by 8. All right, I'm making this image half size. So this one's my final answer for this one, and this one's my final answer for this one, because it's in dimension form, not in coordinate form. That would be type 3. All right, let me erase this right here so that we're not getting confused. There we go. Next slide. All right, same kind of thing. My scale factor is 10, so I'm going to multiply by 10. So that gets me 20 by 100. All right, the next one, I'm going to multiply by 1/3. Multiply by 1/3. The same thing as saying 9 divided by 3, which is 3. Same, I'm trying to do coordinates again. It's going to be 36 divided by 3, which is 12. There we go. Next slide. So this is type 3, example 1. Let's prove triangle ABC is proportional to the smaller triangle. A, here's C, and this must be B right here. We're trying to prove that this larger one is proportional to this one, meaning that this smaller triangle is a dilation of this larger one. Okay, that they're similar. So let's dilate triangle ABC by a scale factor of 1/2. But before we do that, we should write down the coordinates of the original image. So for A, it's 2, 6. For B, it's 2, 2. For C, it's 6, 2. So you can show your work by multiplying by 1/2 like this, or like this. 2 times 1/2 for the x coordinate, and then 6 times 1/2 for the y coordinate, and that would equal 2 times 1/2 is 1, 6 times 1/2 is 3, which equals A prime. Let's check. 1, 3. That works out. Let's try the next one. 2, 2. 2 times 1/2, and then 2 times 1/2. That equals, this makes 1, 1, which equals B prime. Let's check. 1, 1. Okay, works. Let's try the next one. You never know. 6 times 1/2. Uh-oh. Let me erase that. I accidentally ended that. I closed it up. Let's see, 6 times 1/2, and then 2 times 1/2. That equals 6 times 1/2 is 3. 2 times 1/2 is 2. And that should equal C prime. So let's check. 3. Uh-oh. Look, I made a math mistake. 2 times 1/2 is 1. So let me erase that. So 1, which equals C prime, which matches this one. Okay? So this is how you do it if I give you the coordinates. Very, very similar to the dimensions, except the dimensions has this X in the middle for times, like 2 by 10. Think of a 2 by 4. You go to Home Depot or Lowe's and you go buy a 2 by 4. Think of it that way. Or you can think of the dimensions of a picture. Okay? Maybe this is maybe 10 by 9. That would be 10 by 9 for the dimensions of this picture, or rectangle, or just shape, however you want to say it. All right, next slide. All right, dilation type 3, given coordinates. So it says dilate the parallelogram by a scale factor of 2. Well, in order to do that, we should write down those coordinates. So A is -1, 2. B is 2, 2. C is 1, -1. And D is -2, -1. All right, we're going to multiply by 2, so you can do it however you want. I need to multiply all of these by 2 because that is my scale factor. Remember, we got to do it all the way around. -1 times 2, that is -2. 2 times 2 is 4, and that equals A prime. 2 times 2 is 4. 2 times 2 is 4, and that equals B prime. 1 times 2 is 2. -1 times 2 is -2, and that equals C prime. -2 times 2 is -4. -1 times 2, that's -2, and that equals D prime. So it says dilate the parallelogram. We wrote out the coordinates of the dilation, but there's an image here, so we should draw it out. So A prime is at -2, 4. So this is A prime. We're making it twice as big. B prime is 4, 4. C prime is 2, -2. And D prime is 4, -2. So now connect your dots. We just made it twice as large. Okay, twice as large. And if you're thinking about that ray, look. It makes sense, right? They all line up. The vertices line up. Now, do you need to draw that on your papers? No. Okay. All right, next slide. Number 3. So I'm gonna pause this, and I want you to pause this after I'm done talking and try this example, and then come back so that we can check your work. Go ahead, pause it. All right, so it says similar means that all corresponding sides are proportional to one another. You can use a scale factor to dilate. And here are the directions down here. Dilate the figure by a scale factor of 2. So you're just multiplying each one by 2. You can write it like this, or you can write it like this. -5 times 2, 5 times 2, and then tell me what that equals. All right, so A prime would be -10, 10. B prime would be -2, 10. C prime is -2, 2. D prime is -10, 2. We're making it twice as big, okay? If you were looking at this and you're like, wait a minute, those aren't the coordinates I got, that's because this image is unrelated to the question being asked. I put this on here to try to trick you, all right? If you notice, it says this here, this says figure A, so it's the original. This says figure A prime. This means it's after it got dilated. It got smaller. if we're making something twice as big, how would it get smaller? So it's not related. So I hope that you kind of looked at this image. If you looked at the image, I hope that you figured it out, or hopefully you got confused because it was unrelated to the work we were doing on this side on purpose. All right? I wanted you to have that thinking in your head and realize, wait a minute, what's going on here? Okay. All right, next slide. All right, so dilations. If the scale factor is, so if the scale factor is greater than 1, the image gets bigger. So that is called an enlargement. If the scale factor is less than 1, like 1/2, the image gets smaller. It's a reduction. That's what was happening right here. Right? It got smaller, meaning that it had a scale factor that was less than 1. If the scale factor is exactly 1, the image, nothing happens to the image. It stays the same size. But the image is called isometric. Okay. So, remember, if you are given a scale factor and it's greater than 1, so like 1.5, 2, 4, 6, 12, 64, and so on, greater than 1, then it gets bigger. But if it's less than 1, like 1/2, 1/3, 1/4, a fraction, a decimal, then the image gets smaller once you multiply it out. And if it's exactly 1, the scale factor, then it stays the same size. All right, next slide. All right, that's the end.